It's time to start studying for your algebra final exam. But what are you supposed to do? Just read every single page of your textbook? Well, how about instead I just show you the most important concepts that you need to know for your final exam. So here's the first problem, the first important concept. And for this one, we need to solve for x in this inequality. So before we can even deal with this less than sign, we first need to solve for x. And the way that we do that is by getting x by itself. Now, x is trapped inside of this little set of parentheses. But whenever you see this pattern here, where you have a number in front of this set of parentheses, this should immediately say in your head, this is the distributive property. So remember that because there's no sign here, this is multiplication. And what the distributive property says is that when you have a number in front, you have to multiply the number to all of the parts of the parentheses. In this case, there's two parts. So we need to multiply -2 times 3x, and we need to multiply -2 times -1. So -2 times 3x, well, 2 times 3 is 6. And then we have one minus sign, so the minus sign stays. And then the x is going to stay as well. And then here we have -2 times -1. 2 times 1 is 2. And then two negatives make a positive. So this is going to be +2. And then on the right side, we're going to leave everything else the same. The sign's going to stay the same, and the 8 is going to stay the same. So now we've got an x unstuck. It's not trapped inside of parentheses anymore, but we still have to get x by itself. So we need to get rid of this 2 on this side and this -6. I'm going to get rid of the +2 because you should always do addition and subtraction before you do multiplication and division. So the opposite of addition is subtraction. So to cancel out the +2, I'm going to do -2 on both sides. So the +2 and -2 cancel out. On the left side, we just have -6x. And on the right side, we have 8 minus 2, which is 6. And now we just have a one-step algebra problem. And remember, like I said before, whenever you don't have a sign, that means multiplication. So this -6 is being multiplied to x. So to get rid of the -6, we need to do the opposite of multiplication, which is division, and divide both sides by -6. So the -6's cancel out. On the left side, we just have x now. And on the right side, we have 6 divided by 6 is 1. And we have one minus sign, so the minus sign stays. Now notice how I'm avoiding writing this inequality sign right now. And that's because we've just triggered a special rule. So whenever you multiply or divide by a negative number, and you have a less than or greater than sign, then you need to flip that sign. So because we divided by a negative number, -6, less than is now going to become greater than, which means our final answer is x is greater than -1. So here's the second problem that we'll be doing. And for this one, we've got a graph. We've got a line on the graph, and we have to write the equation of that line. So there are many different ways that you can write the equation of a line, like different forms like point slope form or standard form. But whenever you're writing the equation of a line like this, the most important form you need to know is slope-intercept form. And you've probably heard of this equation before. Slope-intercept form is y equals mx plus b. Every equation of a line can be written in this way. So for example, the equation of a line could be y equals 2x plus 1. That's in y equals mx plus b. So y and x are always going to stay the same, but we need to figure out what m and b are and replace them with the right numbers. So what does m stand for? Well, m obviously stands for slope. And they didn't do much of a better job with b because b stands for y-intercept. So to figure out the equation of our line, we first have to figure out the slope and the y-intercept. So let's start by figuring out the slope. Slope is equal to rise over run. But what do rise and run actually mean? Well, we just need to pick out 2 points on this line, and then we have to figure out how much it needs to rise and run to get from the first point to the second point. And for picking out 2 points, you can pick any points on the graph, but I recommend you pick points that are in the corners of boxes so that you don't have to deal with fractions. So for example, this point right here is really good because it's right in the corners of all of these boxes, and we won't have to deal with fractions or decimals. And then up this point right here is also going to be good, and all you need is 2 points. So this is what we need to find the slope. So we're going to start at the point on the left, and we're going to figure out how many boxes it needs to rise and run. So to get from this point to this point, it needs to rise or go up 2 squares. So because it needs to go up 2 squares, the rise is going to be equal to 2. And now what about the run? Running means going to the right. So to get from here to this second point that we drew, we need to run 1, 2, 3 squares. So our run is going to be 3. Now, if this was a fraction that you could simplify, like 4 over 2, that would just be equal to 2, then you would do that. But in this case, we can't simplify this fraction. 2 over 3 just can't be simplified. So in this equation, we're going to replace m with 2 over 3. So now we just need to figure out the y-intercept, or b. And the y-intercept is easier than the slope. The y-intercept is just wherever the graph crosses the y-axis. The y-axis is this big up and down line here, this one left and right, that's called the x-axis. And it looks like it crosses the y-axis right here. So b is going to just be equal to however many boxes up or down this point is, wherever it crosses. And starting from 0, it looks like we need to go down 1, 2 squares. So if we had gone up 2 squares, for example, the y-intercept would be 2. But because we've gone down, those are actually negative numbers. So b is going to be equal to -2. Now this plus minus 2 is kind of redundant. We don't need to have both of those. That's just the same thing as subtracting. So we're going to just turn this into subtraction. It's just -2. So there we go. We've written the equation of this line. Y is equal to 2/3 x minus 2. That's the equation of the line. So here's another problem that involves writing the equation of a line. But this time, all we're given is a point that the line passes and then the slope of the line. So how are we going to write this? Well, eventually we want this to look like y equals mx plus b. That is our eventual goal because that's like the main format for the equation of a line. But whenever you have just one point and the slope, there's actually another format that's going to work really well. And it's creatively named point slope form. So point slope form is y minus y1 equals m times x minus x1. So x and y are going to stay the same, just like before, where we just leave them in the equation. M is equal to the slope, just like before. But y1 and x1 are going to be equal to a point on the graph. So let's go ahead and use point slope form to write the equation of our line. So y is going to stay the same, and that's going to be minus y1, which is the y of a point on the graph. The y of this point is 3, because remember in coordinates, you always have x first and then y. So -2 is x, but 3 is y. So we're going to replace y1 with 3. Now what is m? Remember that m is the slope, and the slope, it says, is equal to 1/2. So we're going to replace m with 1/2. X is going to stay the same, and then x1 is an x of coordinates on the graph. And in this case, x is equal to -2. So we're going to replace x1 with -2. But you may notice here that we have minus -2, and two negatives make a positive. So these are actually going to become positive, and this is going to become a plus sign. So we now have the equation of a line, but we want to turn this back into slope-intercept form. So let's go ahead and simplify this as much as we can. So right here, you may notice that this is the distributive property. So we need to multiply the 1/2 out to the x and then to the +2. So this left side is going to stay the same for now. And then on this side, we have 1/2 times x. You can't multiply a number and a letter, so it's just going to stay as 1/2 times x. And then we need to multiply the 1/2 to the 2. Now, we could go ahead and write this out. 1/2 times 2 over 1, because remember that a number that's just by itself is the same thing as being over 1. So 1 times 2 is 2, 2 times 1 is 2, and 2 divided by 2 is 1. So 1/2 times 2 is equal to just 1. Or you could have recognized that these are actually opposites. So 1 over 2 is the direct opposite of 2 over 1. So when you multiply them together, you're just going to get 1. So now the last thing to do is to move this into slope-intercept form. And the important thing to know is that in y equals mx plus b, y is by itself. So let's try to get y by itself in this equation. The only thing stopping us is this -3. So I'm going to do the opposite of minus, which is plus, and add 3 to both sides. So the -3 and the +3 are going to cancel out. On the left side, we're just going to have y. And on the right side, we're going to have the 1/2 x. That's just going to stay the same. But then over here, we have +1 plus 3. 1 plus 3 is 4. So that's going to combine into +4. And there you go. This is the final equation. This is in slope-intercept form. It's in the same format. Now, I don't know about your algebra class, but when I took algebra, we had to find the domain and range of a graph like 27 times. So how do we find the domain and range of this graph? Well, first of all, what do domain and range mean? Well, domain is basically just all of the numbers that you can put in for x. Or in other words, when we have a graph, what numbers of x does the graph cover? And then range is the same thing, but for y. What values of y could you get out of the graph? Or what numbers for y does the graph cover? So what values of x are possible on this graph? And remember that x is left and right and y is up and down. So for the domain x, well, it looks like we can put in anything we want for x. So like, for example, if we wanted to put in 1 for x, go 1 square to the right, well, that's on the graph. Or if we wanted to go 2 squares to the right, that's also on the graph. See, right here. Now, I know this might seem tricky because what if you wanted to put in 4 for x? And you're like, well, that's not on the graph, right? But remember that this arrow here means that the graph goes infinitely in this direction. And even though this graph is mostly going up, it's always going a little bit to the right. So at some point, you're going to hit x equals 4, and you'll be able to take the whatever y is equal to when you plug in 4. And it's the same thing for negative numbers as well. So if I wanted to plug in -2 for x, that means going 2 squares to the left, then I do hit the graph right here. And it goes infinitely in this direction as well. So eventually it's going to hit every single number for x in this way. So whenever the graph covers literally every single number, we call that all real numbers. Or another way that you might have to write all real numbers is to say that it goes all the way from negative infinity to positive infinity. And the way that you do that is with parentheses. So you'd put it in parentheses and you'd put negative infinity, comma, positive infinity. And this is basically just saying I can put in any number from negative infinity all the way to positive infinity, which means literally any number. Now, what about the range? Can we get any number for y as well? Well, remember that y is up and down. And if we were to just pick any number like 2, 2 is on the graph. See, it's right here. And it's also right here. We actually get 2 numbers for y equals 2. Or if you wanted to plug in 6, for example, 6 is all the way up here. But that actually works as well, because remember, these go infinitely. And you will eventually hit the graph twice as well. But what if you wanted to find out where y is equal to -3, for example? -3 would be 3 squares down, so right here. And you may notice that it does not hit the graph anywhere here. There is nowhere on the graph where y is equal to -3. And the same is true for -4 or -2 or any of these numbers down here. So to find the range, we need to find the smallest number possible for y because it looks like we can get the numbers to be too small. And the smallest number for y is going to be right here. So how far down is this? Well, starting from 0, we need to go down 1 square. So right here, y is equal to -1. And anywhere lower than -1 is not going to be a possible point on our graph. So we're going to write our range like this. We're going to write y, and then it has to be either -1 or it needs to be bigger than -1. So we're going to use greater than -1. And the other important thing to know is that -1 itself, like exactly -1, is included in the range. We can get exactly -1. So whenever you can get the exact number, you have to put a line underneath the sign because this means or equal to. So greater than or equal to -1. The other way you can write your range is just like we did before with here. So we can put it in parentheses and say that we're going from -1 all the way up to infinity because it goes infinitely upward but not downward. And there's actually one more thing that we have to change here as well because -1 is included in the answer. So next to -1, instead of parentheses, we're going to have a bracket. And I know it looks kind of weird having a bracket on the left and parentheses on the right, but that's how you do it because -1 is included in the range, but infinity isn't a number. You can't actually plug in infinity. So that's why we use parentheses for infinity. So the domain is all real numbers, but the range is just y is greater than or equal to -1 because you can't have anything less than that. All right, so here's a problem that's pretty similar to the one that we did at the very start of this video. Except instead of just solving for one letter, we have to solve for two letters, and we have two equations. We wouldn't be able to solve for two letters if we only had one equation. So there are two main methods to solve a system of equations. That's what this is called. And there are substitution and elimination. I personally like elimination better. I think it's faster, but you're free to use whichever one you want. So I'm going to show you what elimination would look like for this problem. The goal of elimination is to add the two equations together. And then when you add them together, you would cancel out one of the letters and leave you with just one letter left. But if we were to add these two equations together right now, that wouldn't happen. Like 3x plus 2x is 5x, and then 2 minus 1, we don't have a number here, so that just means 1. 2 minus 1 is 1, and then 1 minus 4 is -3. Like, we haven't accomplished anything, right? We still have x and y. So to solve this, we need to ask ourselves the question of what number would be really convenient to have. So for example, I think it would be really convenient if this number right here was a 2. Because if this number was a 2, then if we were to add these together, we would do all the math, and then plus 2y minus 2y, those would cancel out into 0, and we would just have x. So I've determined that I really want this number to be a 2. So what do I have to do to make this number a 2? Well, I can't just make it a 2. That's not really allowed in algebra. But I can do the rule of algebra that says I can do whatever I want to both sides of an equation as long as I do it to both sides. So this equation here, I'm going to multiply the entire thing by 2. And by doing that, I'm going to make this number 2, but I'm still obeying the laws of algebra. So this first equation is going to stay exactly the same. But in the second equation, I'm going to multiply everything by 2. So 2 times 2 is 4, so 2x is going to become 4x. Then here we've got minus 2 times y, that's just 2y. And then we have 2 times -4. 2 times 4 is 8, and we have one minus sign, so the minus sign stays. And now let's go ahead and try adding these equations together. 3x plus 4x is 7x, and then plus 2y minus 2y, those are going to cancel out to 0, like I said before. And then that's going to be equal to 1 minus 8. Whenever you get confused about negative numbers, just think of it as money. So you earned $1, but then you lost $8. So you're down $7, so minus 7. And now we actually just have a one-step algebra problem to solve. So 7x is the same thing as 7 times x. So I'm going to do the opposite of multiplication, which is division, and divide both sides by 7. So the 7's cancel out. On the left side, I just have x. And on the right side, I have 7 divided by 7 is 1, and 1 minus sign, so the minus sign stays. So x is equal to -1. But remember that this is only one part of the problem, because the second part is to solve for y. So I'm going to make a note up here that x is equal to -1. So to solve for y, I just need to pick out any one of these equations, plug in -1 for x, and then solve for y. I'm going to choose this equation right here because y is closer to being by itself. So I'm going to rewrite this equation, except instead of x, I'm going to write -1 because we now know that x is equal to -1. And now we just need to solve for y. So this can be simplified here, right? This is 2 times -1, that's -2. And now to get y by itself on this side of the equation, I need to get rid of this -2. So I'm going to do the opposite of minus, which is plus, and add 2 to both sides. So these cancel out. On the left side, I just have, don't make the mistake of just saying we have y. We actually have minus y. The minus signs always have to stay. And that's going to be equal to -4 plus 2. So you lost $4, you got 2 back, but you're still down $2. So minus 2. And now here we have -y equals -2. So how do we get rid of this minus sign? Well, how about I just put another minus sign on both sides of the equation? If we just put another minus sign on both sides, then 2 negatives make a positive, 2 negatives make a positive. So I have positive y equals positive 2. And there we go. Y is equal to 2. So our final answer is that x is equal to -1 and y is equal to 2. And if you wanted to check your work, you could plug both of those numbers into the equations and make sure that they're true. So this is possibly one of the most important concepts that you'll need to know for your exam, and that is graphing transformations of functions. Basically, if you wanted to graph any sort of equation, you could plug in numbers for x, see what you get for y, and then like plot those points on your graph and then connect them up with a line. But for equations like this, we can actually use a faster method called transformations. And to do that, we need to take a parent graph and then make changes to it. So there are a few main types of parent graphs. Possibly one of the most common is just y equals x. There's also y equals x squared, and also y equals the absolute value of x is another common one. So which one do you think we're going to use here? Well, right here I notice that we have a squared, and I know it's not x squared, it's x minus 1 squared, but the basis for this equation is that we're squaring x. So our parent graph is going to be y equals x squared. So the whole idea behind transformations is we're going to graph y equals x squared, our parent graph. And the more problems you do of this is going to be the same every time. And then all we have to do is figure out what adding this to is doing to the equation, is doing to the graph, and then figure out what this minus 1 is doing, and then just make those changes to our parent graph. So let's start by graphing y equals x squared. What happens if we put in 0 for x? Well, if we put in 0 for x, then for y, we're going to get 0 squared. 0 times 0 is 0. So when x is 0, y is 0. And 0, 0 is right here in the middle of this graph. But now what about if we put in 1 for x? Well, if we put in 1 for x, for y, we're going to get 1 squared. 1 times 1 is 1. So when we put in 1 for x, we get out 1 for y. So to represent that, I'm going to move 1 squared to the right because x is 1. And then because y is 1, I'm going to move 1 square upward. And I'm going to put a point right here. So then what about when x is equal to 2? Well, when x is 2, y is going to be equal to 2 squared. And 2 times 2 is 4. So when x is 2, y is actually equal to 4. So to graph that, we need to go 2 squares to the right because x is 2. And then we need to go 4 squares upward because y is 4, because y is up and down. And we will plot a point right here. Now we have a lot of points on the right side here, but we also need points on the left side. And on the left side, those are negative numbers. So what if we plugged in negative 1 for x? Well, for y, that's going to give us negative 1 squared. And negative 1 times negative 1 is positive 1. Remember that squaring always gives you a positive number because we're multiplying two negatives together. So when x is negative 1, that's 1 squared to the left. Y is going to be positive 1, which is 1 square upward. So we're going to put a point right here. And now what about when x is negative 2? Well, then y is going to be negative 2 times negative 2, negative 2 squared. And that gives you positive 4, because 2 times 2 is 4, and then two negatives make a positive. So when x is negative 2, that's 2 squares to the left. Y is positive 4, so that's 4 squares upward. So I think we have plenty of points here. So the last thing that we need to do to graph our parent graph is to just connect all of these points up. And there you go. We now have our parent graph for y equals x squared. Now, I know that that might have seemed like a lot, but remember that every time you graph y equals x squared, it's going to look exactly like this. So just remember that in x squared, a parabola is always going to be this U shape. And just remember that the points are going to be at 1, 1, and then 2, 4, because 1 times 1 and 2 times 2. So now for the transformations part. What is this 2 doing to the graph, and what is this minus 1 doing to the graph? Well, let's look at this minus 1 first here. If this minus 1 or a plus 1, if this was on the outside, then it would move the graph up or down. So if this was a plus 1, it would move the graph up 1 square, or if this was a minus 1, then it would move the graph down 1 square. But because this minus 1 is on the inside of the parentheses here, it's actually going to move the graph left or right. And it's the opposite of what you might think. Negative numbers usually mean to the left, but whenever we're doing transformations, left and right are switched. So negative actually moves the graph to the right, and positive moves it to the left. So because this minus 1 is inside the parentheses, we're going to move the entire graph 1 square over. So this point that was right here is now going to be over here. And then this point over here is now going to be here, and so on. And when we do this to all the points on the graph, we can go ahead and draw our new graph that we have now moved 1 square over. So just to reduce the clutter, I'm actually going to erase our parent graph. And there we go. This is our new graph with the transformation of minus 1. But there's actually one more transformation. What is this 2 doing here, and what is it doing to our graph? Well, remember that from earlier in the video, I talked about how this means multiplication because there's no sign in between. So we're actually going to be multiplying all of the numbers by 2. And in transformations, we call this compressing, and you'll see why it's going to compress the graph. This point right here, this little like vertex, the anchor point, is always just going to stay where it is because that's basically just the same as 0. But this point here, this point is 1 square above the vertex, or you could say it's 1 square above the ground. And because we're multiplying everything by 2, this point that is 1 square above is now going to be 2 squares above. And this point here is also 1 square above our vertex. It's now going to be 2 squares above. Now this point here, this point is 4 squares above our vertex. And now it's actually going to be 8 squares above, which is just off the screen. Like we can't even graph that. So because any other points would just be completely off the screen, this is as good as we can do. So we need to graph our new graph with this point here staying the same, and then these 2 points being like compressed. So I'm going to go ahead and terribly draw our new parabola. So there you go. This is going to be the new parabola. And you can now see why we call it compressing, because multiplying by 2 has actually like shrinked the graph. It's made it like more compressed together. If this was less than 1, if it was like 1/2, it would like expand the graph. So we can go ahead and erase all of our work that we've done before and just leave the final graph. This is the final graph of y equals 2 times x minus 1 squared. So that problem was the last graphing problem of this video, which if you're anything like me, you probably are very happy about that. But now we're going to go over quadratic equations. And for quadratic equations, there are tons of different ways to solve them. So I'm first going to go over how to factor quadratic equations and then how to solve them by completing the square. So how do we solve for x here by factoring? Well, remember that in a quadratic equation, x shows up twice. We have x squared here, and then we just have x. And we can't get x by itself the normal way because there's no way for us to combine these, an x squared and a regular x. So we have to do special methods. So factoring is usually a lot easier when you don't have a number in front of x squared. Like if this was gone, then we could just do the easier method of factoring. But because we have a number in front of x squared, we have to use the x method. So I'm going to go ahead and draw our x right here. So in the top of our x, we're going to multiply this number right here. And remember, the minus signs always stay. So this number here and the number in front of x squared. And when we multiply these together, we get 2 times 6 is 12. And then 1 minus sign, so the minus sign stays. So this number right here is going to be the number that we try to multiply to. And I'll explain that in a minute. But for now, we need to figure out the number that's at the bottom of our x. And that's going to be the number that's in front of x. But there is no number in front of x. But remember, that just means that there's an invisible 1. So at the bottom of our x, we're going to put 1. And this is the number that we're trying to add to. So we need to find 2 numbers that multiply to negative 12 and add to 1. So I'm going to ignore the minus sign for now and find 2 numbers that multiply to 12. Well, the obvious one is 1 times 12. 1 times 12 is 12. But we are multiplying to negative 12, and I know that the negative sign needs to be on the smaller number because we're adding to a positive number. If we were adding to a negative number, then I would put the minus sign on the 12 because that's the bigger number. So when we multiply these together, we get negative 12. But if I was to add them, we would get 12 minus 1, which is 11. And we're just looking for 1. So 11 is way too big. This is out. What about 2 times 6? 2 times 6 is 12, and I'm going to put the minus sign on the smaller number because we're adding to positive 1. If we add these together, we get 6 minus 2, which is 4. That's still not what we're looking for, but it is closer. The only other option we have is 3 times 4. 3 times 4 is 12. I'm going to put the minus sign on the smaller number. And negative 3 plus 4 is the same as 4 minus 3, which is 1. And 1 is the number that we're looking for, right? So our 2 magic numbers are negative 3 and positive 4. So let me go ahead and explain what we're going to do with those numbers. These magic numbers, negative 3 and 4, are going to go on the left and right sides of our x, like this. But those aren't just going to be our final magic numbers because we now need to divide one of them. We need to divide one of these numbers by positive 2 here. And this -3, I wouldn't want to divide this by 2 because that doesn't simplify and we're dealing with fractions. But what if I divided 4 by +2? Well, 4 divided by 2 is 2. So I'm going to go ahead and do that. I think that makes more sense. So our two final magic numbers are -3 and +2. So let's go ahead and put that into a factoring equation. We're going to have two sets of parentheses here, like this, and those are going to be equal to 0. And in the parentheses are going to be our two magic numbers, -3 and +2. Now, if we were doing the easy method of factoring, these would both just be x. But actually, because we're doing the hard method, because we have a 2 in front here, one of these has to be 2x. And the one that we put a 2x on is always the opposite of the one that we divided originally. So we divided this 4 by 2. So because we divided the 4 by 2, the 2x needs to go on the -3. And let me go ahead and explain to you why that is. You may have heard of this thing called FOIL, where it's like first, outer, inner, last. So you multiply the first parts and then the outer parts and so on. That's basically how you would multiply two binomials, to multiply two things in parentheses to get the equation. And if you were to do FOIL on this, you would end up multiplying the 2x by the 2, that's for outer, and 2 times 2 is 4. So you would end up with 4x, which is what we had before we divided. So by putting the 2x on the opposite side as what we divided, we basically multiplied them together and got what we got originally. So this is our final factorization. We have two sets of parentheses and they equal 0. Well, what do we do from here? Well, there's a special property here because we're multiplying these two parentheses together and they equal 0. What happens when you multiply something by 0? Well, it becomes 0. So if this happened to be equal to 0, the whole thing would be 0. Or if this was equal to 0, then we'd be multiplying by 0, and the whole thing is 0. So because this is equal to 0, we can actually split this up into two equations. So I can split this up into 2x minus 3 equals 0, and x plus 2 equals 0. And now I just need to solve for x on each one. So 2x minus 3 equals 0. I'm going to get rid of the minus 3 first by doing the opposite of minus, which is plus. And I'm going to add 3 to both sides. So these cancel out. On the left side, we just have 2x. And on the right side, we have 0 plus 3, which is 3. Now, this is multiplication, right? 2 times x. So I'm going to do the opposite of multiplication, which is division. And divide both sides by 2. So the 2's cancel out. On the left side, we just have x. And on the right side, we have 3 divided by 2. That cannot be simplified. So it's just going to stay as 3 over 2. And this is one of our answers. But we are going to get a second answer from this equation. Whenever you solve quadratic equations, most of the time they're going to have two answers. Not always, but most of the time. So I'm going to get rid of this plus 2 by doing the opposite of plus, which is minus. And I'm going to subtract 2 from both sides. So these cancel out. On the left side, we just have x. And on the right side, we have 0 minus 2. This is 0, isn't doing anything. So this is just going to be minus 2. So we've now found our two answers. X is equal to 3 over 2, and x is equal to minus 2. So here's another example of solving a quadratic equation, but this time we need to use the completing the square method. Well, the goal of completing the square is basically to make a perfect factoring situation. So for example, let's say you were to factor this and you were to get your two sets of parentheses, and they would be x minus 3 times x minus 3, right? They're both exactly the same. Well, if you multiply something by itself, then that's the same thing as squaring. So this is the same thing as x minus 3 squared equals 0. And then this gives you the opportunity to just get rid of the squared by square rooting both sides, because that's the opposite of square. Now, this is not going to give you that perfect factoring situation. I mean, that's pretty rare. But we can actually force it to have that perfect factoring situation. So before we do that, it's just going to make our lives easier if we get rid of this number by itself and move it to the other side. So I'm going to do the opposite of minus, which is plus. I'm going to add 7 to both sides. These cancel out. On the left, we just have x squared plus 6x. And I'm going to leave this space here. You'll see why in a minute. And on the right, we have 0 plus 7, which is 7. So now the reason I left this open space here is because we need to figure out what magic number should go right here that would turn this into that perfect factoring situation. And the way that we do that is by actually using this number. So to find out the magic number, you just need to take the number in front of x, you need to divide it by 2, that gives us 3, and then you need to square that number. So 3 squared is the same as 3 times 3, which is 9. So that's the important thing to remember. You divide by 2, and then you square it. So the magic number is 9, and that means we're going to put plus 9 into the space. But remember that in algebra, you have to do everything to both sides of the equation. So because I'm adding plus 9 here into this side of the equation, I also have to add plus 9 to this side of the equation. And that's going to give us x squared plus 6x plus 9 is equal to 7 plus 9, which is 16. So now we know that we're going to have our perfect factoring situation, and now we just need to factor it. But I know you probably don't want to do that whole factoring process again that we did before. So there's actually a shortcut we can use. You know when we divided by 2 and then we squared it? When you divided by 2, we got 3. This number here is going to be our magic number. So when we factor this, we're going to get x plus 3 squared is equal to 16. It's always going to be the number that we got when we divided by 2. And if you weren't sure of that, you could check your work by doing x plus 3 times x plus 3. You could multiply it out and make sure you get this. So now our final step is to get x by itself. But x is trapped in these parentheses, and we have a squared here. So let's do the opposite of squared, which is square rooting. I'm going to go ahead and square root both sides. So the square root and the squared cancel, and on the left, we just have x plus 3. But on the right, we have the square root of 16. But it's actually not just the square root. Whenever you're doing a math equation and you square root both sides, what you're actually doing is plus or minus square rooting. So the square root of 16 is 4, but that's actually plus or minus 4. And by the way, the square root of 16 is 4 because it's 4 times 4 is 16. It's what number do you have to multiply twice to get 16. Now I'm going to move this part up to the top so that we can continue the problem. So this plus or minus means that we have an equation where this is positive 4 and one where this is minus 4. So we're actually going to end up with 2 different equations and 2 different answers, just like the last method that we did. So I'm going to split this up into x plus 3 is equal to positive 4, and x plus 3 is equal to negative 4. And we'll go ahead and solve both of these. So on the left, we have x plus 3 equals 4. I'm going to get rid of the plus 3 by doing minus 3 on both sides. And this is going to leave us with x is equal to 4 minus 3, which is 1. So on this left side, x is equal to 1. Let's go ahead and solve the right side now. We'll get rid of the plus 3 in the same way. We'll do minus 3 on both sides. So these cancel out. On the left side, we have x. And on the right side, we have negative 4 minus 3. So you lost $4 and then you lost another $3. So you're down $7. So negative 7. And there you go. We found out our 2 answers. Our 2 answers to this equation are x equals 1 and x equals negative 7. All right, for this problem, we're going to need to be doing a little bit of simplifying. And by simplifying, I mean we're going to be multiplying these 2 sets of parentheses together because there's no sign in between. So earlier I talked about this method called FOIL, which is where you have, like, for example, x plus 2 times x minus 3. And then you go first, outer, inner, last. But this is a little bit more complicated than that because we have 3 parts in this set of parentheses instead of just 2. So we're going to be doing like a slightly more complicated version of FOIL. And it's actually also a slightly more complicated version of the distributive property, but it's all kind of the same thing. So what we need to do is we need to take this first part here, the 2x, and we need to multiply it out to every part of the other set of parentheses. And then we need to take the 3 and do the same thing. So let's start with the 2x. We need to multiply 2x times x squared. So 2 is the only number here, so that's just going to stay as 2. And then we have x times x squared. Well, remember that x squared is x times x. So this is x times x, and then we're multiplying another x. So that's actually x to the third. Next, we need to multiply the 2x to the minus 4x. And remember, the minus signs always stay. So we have one minus sign. The minus sign is going to stay. 2 times 4 is 8. And then x times x is x squared. Now, what about 2x times positive 2? That's the last part here. 2 times 2 is 4. And then we have 1x, so the x is going to stay. And no minus signs, so that's going to be a plus. So this is our final multiplication for multiplying 2x out to all the parts. But remember, now we have to multiply the 3 out to all the parts. So let's go ahead and get started with 3 times x squared. Well, you can't multiply those. We have a number and a letter. So that's just going to stay as 3x squared. And I'm actually going to put this under the other x squared. And well, you'll see why in a minute when we add them together. Next, we have 3 times negative 4x. We have 1 minus sign, so that's a minus. 3 times 4 is 12. And we have 1x, so the x is going to stay. And this is going to stay under the other part that's just with an x. And then 3 times 2, they're both positive, so that's a plus. 3 times 2 is 6. So we've done distributive property with the 2x, that's this top part here. And we've done distributive property with the 3, that's this other part here. So our final step is now to add these two parts together. So I'm going to draw this big line under here, and we're going to add these together. So 2x to the third, there's no other x to the third to combine with this. So it's just going to stay as 2x to the third. But here we do have some combination going on. This is adding, by the way. So negative 8x squared plus 3x squared. Think of it as dollars like before. You lost $8 and you got 3 back, but you're still down $5. So that's going to be minus 5. And remember that when you're adding and subtracting, you don't do anything with the exponents. It's just going to stay as x squared. Here we have plus 4x minus 12x. So you got $4 and then you lost 12. So you're down $8. So minus 8x. And then this plus 6 has nothing to combine with, so that's going to stay as plus 6. So there you go. When you multiply these two sets of parentheses together, you get this 2x cubed minus 5x squared minus 8x plus 6. It honestly looks more complicated than this, so would you call this simplifying? I guess. So one of the topics in algebra that I feel like a lot of people struggle on is long division, when you're dividing polynomials. Remember that a fraction is just the same thing as division, so if there was a divided by symbol instead of a fraction, that would mean the same thing. So to do this, we're actually going to do the same thing that you would have done in your elementary school class where you did long division, but we're just doing it with algebra. I know it's a lot harder that way, but it's kind of the same method. So this top part here, the first part of our division, we're going to write here, and we're going to put it inside of our division box, like this weird thing. And then on the bottom, this part here is going to go on the outside of our division box. And now we just need to follow the same steps as elementary school long division, which if you don't remember them, those are divide, multiply, subtract, and then bring down. And in the wise words of my elementary school teacher, you can remember this by the acronym, does McDonald's sell burgers? By the way, in case anyone was wondering, yes, McDonald's does sell burgers. So the first step is to divide. So we need to divide the first part of the inside by the first part of the outside. So 2 divided by 2 is 1. And by the way, our answer is going to go on top here. And then x squared divided by x. So think of this like x squared divided by x. X squared is the same thing as x times x. So 1x from the top and the bottom are going to cancel out. And that just leaves us with x. So this is going to be 1x, but we don't have to put the 1 here. That's unnecessary. So this is just going to be x. That's our division. The next step is m, which is McDonald's. Multiply. And we need to multiply this entire thing to what we just got as our answer here. So 2x times x, that is 2x squared. And then 3 times x is 3x. So division you only do with the first parts of each, but multiplication you have to do with the entire thing that's on the outside of our division box. The next step is to subtract. So we need to subtract these here, like this. But if we were to just add these together, that would be adding. So to subtract, we basically just have to change all of the signs on the bottom. So those were both pluses. These are now going to become minuses. Or if they were already minuses, you would make them pluses. And now let's go ahead and subtract. So 2x squared minus 2x squared, those cancel out, those turn to 0. And then minus 5x minus 3x, that's minus 8x. Think of it as dollars if it confuses you. And now the final step is b, which is to bring down. And the only thing to bring down is this minus 10. So let's bring it down to the bottom. and we just have to repeat the process. We only have to repeat it one more time because we've brought down everything we can. So first is division, divide. So negative 8x divided by 2x. 8 divided by 2 is 4. X divided by x, those cancel out both of the x's, so that just doesn't do anything. And then we have 1 minus sign, so the minus sign stays. Next is multiply. So 2x times negative 4. 2 times 4 is 8. The x stays. And then we have 1 minus sign, so the minus sign stays. And then also we have to multiply the 3 by the negative 4. 3 times 4 is 12. And there's 1 minus sign, so the minus sign stays. Next is to subtract. And remember that subtracting means we have to change all the signs on the bottom. So these minuses are going to become pluses. So negative 8x plus 8x, those cancel out. And here we have negative 10 plus 12. That's the same as 12 minus 10, which is 2. So as long as this number here at the bottom is 0, we're done. That's it. And this part right here, x minus 4, is our answer. But this is not 0. So that means we have a remainder. And dealing with a remainder is actually pretty simple. We just need to attach it to the end of our answer. So our remainder is going to be plus 2, but the 2 has to be over divided by our part that was outside of the division box. So we have to divide it by 2x plus 3. And that's all you have to do with a remainder. You just attach it to the end and then divide it by whatever we divided by originally. But yeah, this part at the top here, whatever you have left here is going to be your final answer. So our final answer is x minus 4 plus 2 over 2x plus 3. So there you go. Those were the most important things that you'll need to know for your final exam. And honestly, the best way to study is to practice. So keep doing practice problems like this, and you'll be ready for the test. Now, those were the most important things, but there were a lot of topics that I wasn't able to cover in this video. So if you're looking for some more practice, then you can watch this video right here, where I go over some more problems that you'll need to know for your final exam. And if you have any questions about any of the problems in this video, go ahead and leave a comment, and I'll be sure to answer your question. Good luck on the test.